Okay, good morning. I'm going to talk about adding a Lua-based integrated character-based menu system into the SciTE editor, or SciTE. I don't know what it's called. I've been calling it SciTE, so I haven't heard what they call it. And I'll just used to saying that. Let me give you some background. Okay. In 1988, I started using the Borland's DOS-based Sprint word processor. Anyone ever heard of that? It lasted a year or so, but it was fully customizable. It had an Emacs-like macro system, but it was forth-based in implementation, which was really hard to learn, but it worked really nicely. Had a formatter, which gave scribe-like formatter macros, printer and screen customizations. And so the whole word processor, which I ended up using for programming, fit on a 720 KB disk, ran nicely on one of those old Model 30s, IBM PCs, had the spell checker, thesaurus, and all of that. But so a macro processor, you've heard of TeX from Donald Knuth. That's one in the C++ macro preprocessor. The formatter macros are not the same as editor macros, and I needed to be able to do this in SciTE to get full control over everything, so I want to give the background. Anyone ever heard of WYSIWYG? What is WYSIWYG? Oh, yeah. What you see is what you get. Now, if you use Microsoft Word is WYSIWYG. It's what you see is what you hope to get. And someone said, what you see is all you get. If you want to change it, it's a major effort to go through and change everything. The way to get around that, editor macros, like VBA editor macros in Office or whatever, they change what you see. They're going to change all you get when you do that. A formatter macro can change what you get. You can get different things. But it introduces another step. You have the edit, compile, run step, which became the edit design, where you have visual design, compile, link, run step. But you add an edit, format, compile, or run step. You're formatting in between. And you can do lots of nice things with that give you aspect-oriented programming and so forth. Okay, I'll just show that later. 2 years ago, I needed to go to get rid of the old editor. It was DOS-based. It worked well till XP, but I needed to go up to 16 gigabytes to run all these programs, and it wouldn't run in the XP mode very well. So I needed to replace it, so I was looking for a new editor. I went looking around. I found the source site editor based on the Scintilla components, and it said it had Lua support for scripting. I was looking for scripting. Some proprietary editors have JavaScript with this huge document object model for doing the editor. It just looked like a mess. So I said, what's Lua? Checked it out, and I've been using it ever since, Lua, for a number of different things. And Mitchell, you who gave the presentation yesterday, what was that, Text Adept? Yeah, and I found out he had requested an Onkey part in Lua that lets you manage every keystroke. Well, I use that, and that was the deciding factor. Okay. So I wanted complete customization. I need control of every single keystroke that comes into the editor so I can do whatever I want it to do. And I had worked on this before 1988 with the GML macros and the mainframe and so forth. But yeah, I needed control over everything, and this let me do it. Okay. And part of that, let me show here's an editor. Here's a file. I think this will work. When I press the page down key, what should happen? You go down a page, right? Well, going way back, now look, I don't like that. It's supposed to go up. But I like, if I press page down, this is supposed to go to the top of the screen. And if I'm up the top of the screen, it'll go the whole way down. Now, to do that requires, to do context-sensitive actions in your editor, you need to process the keystrokes and get in there. So when you do the page down, page up, whatever key you're pressing, the editor can look at where you're at and decide so that you can overload this key with many different functions. Now I'm going to show some features I put in, then I'll get to the Lua code that did it. Now, when you're processing, handling every keystroke, one of the things comes up is, I don't like the way that's working. I want to change it. So one thing you build in, I put it, and this is in the main keystroke. I'm going to press a key, then the page down. And wherever I'm at, the editor knows, okay, this next keystroke is not to be actually done. I want to go to the actual Lua code that implements this keystroke. Because when you're changing this stuff, oh, I want to change this, I want to change that, you want to go, there's the page down, and here's what it does. If we're at a certain line, it'll do this. Otherwise, it'll do this and shift. And the site has this output area in the right for debugging and to see what's happening, and I'll turn that on and off as needed. So features like that, where you want full control of what's happening, you need to be able to process each keystroke. Now the macro part is I'm going through a formatting stage. So this says if 1, which is 1 is true, I'm going to do this. So it's going to print something for me. If I didn't want to see that, I would change it to a 0. It turns gray because of the lexer. It means now it's not going to appear. So what I see is not what I'm going to get. But by making simple changes through variables or codes, I can change what I'm going to get. Then I can automate that from the outside and get different outputs from the same source file. Now, where do keystrokes come from? Because we have to know where they come from and where we can get them from so we can add more options to our system. Well, we get them from the keyboard, right? And we have the numeric keyboard and so forth. Anyone ever seen a G-13, Logitech G-13 gaming keyboard? Yes. So it gives you 20-some keys in different modes, and you can customize all those to do separate things for you. Now, Logitech actually has Lua support for this, but it's kind of a crippled Lua support. You can't do much. It's a pain to use because of the limitations Logitech put on it. But it is good because you can set up it to send keystrokes somewhere else. So by default, I just have one script, Lua script, and it sends all the keystrokes, changes them, and sends them to AutoHotkey, which knows how to manage keystrokes. And those get sent to the site editor, and then my menu system will handle that. That gives me all these extra functions over here. Now, in Windows, you have things like Control, Alt, Shift keys, right? Does anyone ever use Control, Shift, or Shift, Control, Alt, 1 when you're typing? How about Shift, Control, Alt, A through Z? No. Well, those can then be used. So you map these exotic keys that don't have keystrokes to those ones you're never going to type. And then the editor can simply handle those as, the way they come in and do some action for you. So it gives you a way to get more keys. I've been using this Wave keyboard, the wireless one. They have a wireless one, and it's like $80 or something. Comes with a nice mouse with it, wireless too. And you have see these keys on the side? This. You can add all these keys and have them do things. And you set them up to some Control, Shift, Alt, or something, Control, Alt something that you're not going to use, and map those to actions. I never use the numeric keypad for numerics. I'm not an accountant. I don't type in numbers all the time. Well, you can differentiate those, so you can map those to other keys too. Now you've got a whole other set of things you can do for actions. And they have this function key which turns these function keys into other actions, so you can do that. Point being, you have all these keystrokes which you can map to things that you want to do to save you typing or do things for you. Okay, so we got all those things we can do. They're coming into the site editor, and Lua is going to let me process each one of those and handle them. Okay. Now the menus, I wanted to hook a menu system in the site, and it wasn't, it already had its own menu system. And I'm not going to touch that. I'm going to leave that alone. Because I don't want to, all they do is they let you add some menus somewhere over here. Let's see, where's that? Tools. You can add some of your own menus here. Well, that's only a few menus. I want control over hundreds of menus, or a lot of them with hundreds of actions. So we have this auto-completion facility in SciTE. And what it lets you do is it lets you auto-complete, right? You fill up a list, you put actions with it, you call it, it displays something, you have like a callback function, you can then call that function, it'll do something. Well, the old Sprint editor put the menu at the top. I'm going to live with my menus anywhere they are. I can still use autocomplete. It's just I have control. I can use this as a menu system. So I have, and some of these are holdovers from what I used to use. So I now have a way to get a menu system. The author of SciTE said that, well, you can't change the color that's built in or something, so you have to settle for that color. So I've got a way to display menus. When I do actions, I now need a way to hook that in to the site editor. So all these things have menus or actions. I can do all sorts of things. You have to kind of remember where they're at. I go, there's the F10 menu. Well, I decide I want to change that. I'm going to press my special key and press F10. And it took me to my F10 menu. So I can now change it. Now the color coding here is part of the formatting system, because I don't want to write all this Lua code manually. So I'm going to have a macro that's going to handle this and generate what I'm going to show you, because you could do it manually, but it's not that easy. One of the things I needed was the color coding, which I just got used to doing this. Some of this goes back to the original Borland editor. But let me press this up. Those underlying keys are actually control keys in the editor, Control A through Control X with a few exceptions. And so I needed a way to do a reveal codes so I could see the underlying codes in all of the macro or the formatter, the source code. That's a Control O. That just means that's a macro definition. Now here's a talk I did yesterday, and I pointed this out. Here I have a macro where I'm actually going to run Lua code when I'm in the formatting process. And that allows me to do all sorts of neat things. I'll just show. If I were writing a program in Lua and I wanted a macro, you might write if something, then, and you do something with it, right? Now, if I want to do it in a macro, I might type in if then. Let me see if I can make that a little bigger. Oh. And that, let me delete that. So I might go if, then I'm going to, oh, it's supposed to kind of didn't do that. And I put in here my condition, right? A equals B. So I might put that in. Okay, what's the if-then macro? Just to give you a flavor for this. Well, let's come over to where that's at. Here's the if-then macro defined at the top. It's color-coded through the lexer. I needed a custom lexer. I don't think LPEG would work, although I want to look at that. And for historical reasons, it's called this. There's no Lua in here, is there? I haven't done that yet. So if I'm going to have Lua code, how do we write Lua? If there's no begin there, right? So now I could have this output as Lua code. VB, ASP, VBA, VBS all use this form. Pascal uses that. C#, PHP use this form with the parentheses. So I can now write code in the formatter, and I can output it in any of these languages. so I can abstract a lot of this away and not have to remember how each is different. So in a lot of cases, I have macro code. PHP and ASP are very close, so I have some code that works the same for both. C# and VB are very similar. You can't do everything, but you can do a lot of that. So that's flavor of what I want to do there. So if I have a new language, new system, I can use some of the same old code. I just have to fill in the macros for that. Okay, now SciTE also, I hooked in, let's move over to back to the, here's the actual notes where we're seeing this. Microsoft, let's put a, you can hook in the spell checker. That's fun too. I think the Hunspell DLL, which they have, which hooks into Lua, so you can actually do your own spell checking. You have the autocompletion. What I showed you before was an active template. So if I type in, I want a function. Oh, it's not. Oh, I know why it's not working, because I'm not in the right form. Anyway, let's see if it works over here. Function, and they ask me for a name. I want this to be the process function. It's now going to fill in the process with this. I'm going to go down to the body. I'm going to type what I want in here with that, and so forth. Now, the way that's implemented, the Borland also did this a few years, and this is all done in Lua. We want a way to edit that. I just use Control to open. Sorry, I want the. Oh, that's a specific one. There's either an all or the. There we go. I create a text file that has. It's a file, takes you to it. I want to put in a function name. I want to then replace that function name in my code. And then these are places where when I hit tab, we'll go to and I'll fill them in. So Borland had that a few years back, and so I just did that in Lua. Okay, back to where let's go back to this. I showed those. I added Linux support because it was neat because I can now do editing in Linux using the same editor format that I do here. I had to figure out the Dvorak keyboard layout because I was using that, and it was bottom up. I just typed a key and found out which one it did. So I added that into the editor through Lua. That is, I come in here, I hit T to toggle keys, and now in this output area, it's going to show me every key code I'm putting in. So if I'm not sure what's happening when I press a key, I can do that. Okay, let's see let's get into a little more details. So that's a little bit how it works. Let's look at one of the key functions, the onKey function. I had to put some things in for Linux. The onKey function is going to call, in case there's an error, it's going to use pcall, transfer to the onKey1, return the result. If it's not okay, it's going to let me know that there's an error here because there's some code that needs changed. Otherwise, it's called this onKey1 function. Now, the onKey1 function is going to have a list of array table I'm going to get to. If the state, and you have to maintain a state because sometimes when it switches between buffers, you need a way to remember things in the other buffers because of the way it was implemented. So I just do it that way, and I manage the session and everything myself. Okay, if there's nothing defined, if that key is not defined, we're going to do something here and just put a message up there, do something saying, you pressed a key that's not defined, which means I may want to define it. It means I may not be using it yet. It's available. Otherwise, we'll look at this array in a second. I'm going to look. I need to determine if there's a help function that needs to be done. And I'll set the help variable depending on what keys are pressed. because I need to let some keys go through to that menu, so you can do up and down. So I'm going to let those go through. If it's help, I need to do something else. Now, if the help is set, that means I want to go find the help in the Lua source code. And this is dependent on how you've programmed your Lua, and you have to write the routines to open up that file and take you to where that code is defined. But there are only a few patterns that fit, so you work those out and you have it come in. I needed to put some, if it's that G-13 keyboard thing, I needed to handle that special, so that's in there. Okay. Otherwise, it's not 0. We're going to come in and we're going to convert that to a character. We're going to look through a menu list and see, is there something defined for this? Yeah, because 2 minutes a menu. If it is, if there's something happened and it's not in the menu, we'll do that. Otherwise, we're going to find the menu and then close it. Because we've got to do several things. If you have a menu open, you have to know it's open. The Lua code knows it's open. It knows you're going down. So when you press either Enter at where you're at, or you press the first letter, because I use A through Z, 0 through 1, which are automatically put in there, then it knows we need to go find the menu and do it. Now, if the completion is active, that means there's something menu up there. I need to check, and I may need to close that menu. However, it's up there. And down here, I'm doing something, and then I'll go to the menu, and we'll look at that in a second. And then I check a status. This part I just added last week. They have a feature you can add a strip of input area, but there were some problems with that, so there's no, right now you can't tell because of the limitation of SciTE. Next, this key array is going to have functions which are called, these are functions with no arguments, which are called based on what key you press. So I go through and check Shift, Control, Alt. Those are those ones that would normally come through from those other devices. And this key 3 array or table has a list of these. You know, if they're all down or 2 of them are down, and I'm going to do each of those keys, or call the function for them. So I've got this long table which is going to be semi-automatically generated. And we get down here, and finally, if there's nothing there, it'll just give me a little warning saying, oh, this key you pressed is not mapped. So the original key arrays, it's a long array, semi-automatically generated. 65 is what the ASCII code for A, uppercase A. So, oh, actually, yeah, it's uppercase A, but these are using the Windows virtual key codes. Remember, in that key, if I were using Linux, I had to remap the Linux ones to the Windows because I put the Windows in first. I wasn't going to go through and change everything, so that way in Linux I just map them to the ones that are already there. Then we have here 0 through 111. Those are the 8 possibilities for the Shift, Control, Alt. And there is a function for each one. Each one, it doesn't take any parameters, and it has to know what it's going to be doing. Now, each of those functions, this was the one for virtual code 65, the uppercase A, and it has to know what it's going to do. If there's a lowercase a, if the shift is not down, nothing's down, it's a lowercase a. If the shift is down, well, it's an uppercase A. If it's a control A, it's a shift toggle 2. Shift control A is not mapped. If it's Alt A, it's a toggle on that key. So for example, if I select stuff, what the A does is it just reselects what was there. I did not like in Windows where you have a selected area and you move the cursor and your selected area disappears and you can't move away, so it The Lua code takes care of, like the Sprint editor did, remembering the last selection you had. So if you want to go back, so if you move that, you can still have that old selection there. And what it does is every time when you toggle it here off, it takes you to the beginning of the selected area. When you do it two more times, it goes to the end. So you're toggling back and forth from the beginning to the end of the selected area. Just little things you can put in, but you need control over the keystrokes, and you need a way to manage those, in this case with Lua. Now the Alt-A, what that does is put in a color-coded, I can't type on here, this is Alt-A text. And if I reveal codes, I'll press it. That one. The Alt-A puts in a Control-A and ASCII character 1. And that gives me a color-coded text. And let me turn that. Now, what is Alt-A? I'm going to put a macro in. A equals what Borland did is they mapped Control-A, which can be in the editor, with a color coding to a macro name in the formatter, so I can redefine what the A macro does. It could be something complicated, but still see it here in a color-coded form without all the extra text around it. The other way to do it is to do Control-A, O-A. Those are exactly the same, except when you have a whole file loaded with these, it's hard to see what's going on. You can color code these to be what you want. Now, if I leave that in there, that's going to mess up everything. Let me do the if 0 and move that down. Okay, that way, when I format it, it's not going to mess up what I'm doing. And you can do other things. When you type in a left bracket, what's the next thing you usually do? Aren't you going to type in a right bracket? So if you have control, you can set it up to look at where you're at and decide, when I type the left bracket, there we go. I use the Dvorak layout, and this isn't labeled for that. It put in my right bracket for me. Now, it does that only for most files. If I put in a parenthesis, it's going to add that. Oops. If I put in a quote, it's going to do this, and it's going to color code it. So the lexer, of course, will handle, put a little red mark in there if it's not matched, which is what the lexers are supposed to do. So again, this is not functionality built into the editor. This is what you get when you can decide what you're going to do through Lua with what happens with keystrokes. Okay. Now, menus, like when you press F1, then you end up calling a menu with a unique code. There's going to be a list from that menu on what to do, what to display, and what actions to do. And I'm using those formatter macros to actually create these because I don't want to write that all by hand. You could, but I don't want to. Now, I'd used this method early on. Later, I realized I could use an associative table, but I haven't done that yet. So here's the F1. It's going to have, and this is semi-automatically generated from the formatter. It's going to have a list of what the letters will be that you type if you want the shorthand for it. Then it's going to have the text you display in that menu. Then it's going to have the function that's called when you press that key. So this is F1, so if I go over and press F1, it's going to display that menu. And if I press my special key and go there, it's going to take me to the code that does it. So the macros here, the menu add, item adds with the what it is being called, that's all handled in the formatter macros, so I don't have to actually write all of those tables, which is what the formatter is for. Now, when you do menus, here's the Lua code for that. It's if there needs to be an escape action, and if that's not set, you provide a default that does nothing. Because when you press escape, you want something to happen depending on what you did. Put a warning here. If the menu is already active, that should never happen, but it lets me know. Actually, when you put the menu up, I had this in because I thought you could change colors, but then he told me you can't change the colors on them. I set some parameters on how that auto-completion will appear. For now, it looks through and it puts a little list at the bottom of the menu if I've used a one more than once. So when I press F1, you see here at the bottom, I just thought, oh, I really need that. So if I want to know which keys I haven't used yet, and I want to put one in, it just lets me know, I haven't used these keys yet. I could pick any of those letters and not conflict with the existing menu. There's a menu escape. Menu close. You can close the menu. Because once you set the menu up, the Keyroutine knows that this menu is up. You set a few variables. Global ones are in the state table. So it knows what menu's up. It knows which things are legal actions. Then when you press the key, it can then match the letter you pressed or the enter of where you're at with that particular menu. So the menu key is going to handle if you can escape from it. If you press enter, you have to know where you're at, and you do that action. If it's there, if it's this key, that's the one I picked. You want help. Oh, so if you press a menu and press F1, it takes you there. Otherwise, and this is where I need the associative table, but I haven't done that, it looks for the key in that list. It finds the action. It's found the action. There are several ways you can get an action. Then, if we're done, we're going to close the menu. We're going to do the action and then set the place where we're at in the menu to 0 so the on key doesn't still think we're in the menu. Now, one of the problems you can have is if you have all this menuing keystroke code in your editor and you go to change it, what happens if there's an error? Well, it doesn't work right, because what you have to do in SciTE is you have to close SciTE, which I have a perm will tell it to close, then it'll reopen it. If it opens and there's an error, things don't finish. And what do you do when you need to change your menu keystroke code, but the way you usually do it is now broken? Right? And so what I've been doing gradually, I've been checking out the modules and the P calls and gradually moving routines out so they're more dynamically loaded through Lua, so that if there's an error, Lua doesn't simply crash and say, oh, I couldn't load all the code, because then you're stuck. In the meantime, what I have it do is if there's an error, it will then gets displayed in the output. I can then press, it takes me to the source, the generated code where it's at, and then I change that and then reload it, which I have another button to do that. So that's one of the problems, and I've been working on ways to handle that in a little bit better fashion. Okay, so that's a little bit on how to add a menu system and keystroke handling to, in this case, the SciTE editor. Because once you do that, you get full control. Now, I skipped over. If you return, in that on key, if you return true, you can simply let SciTE handle the menu, the keystrokes. So sometimes I want to do that. Sometimes I don't. So you can let SciTE handle it. And I can still, even though I've disabled all the menu system, this menu system, it's disabled as far as the shortcuts go. I can still go up here and pick an option out of it. Or if I really wanted to, I could simply have that keystroke return true, and for that keystroke, let SciTE handle it as a menu. So you can simply add new things as you need to in order to customize your editor. Last thing I'll mention from the formatter, so here are the notes, like here was Microsoft Word is WYSIWYG. And one of the things you get from being able to use a formatter, and I was doing this in the mid-90s, I started doing this for HTML, because HTML came out, 95, became popular. So I adapted this to generate HTML, even though this editor had been discontinued 5 or 6 years before. It had the flexibility to add that. So I have different versions. So if I'm in web mode, right now I took this and I generated the slide view. That's that slides you were watching in HTML. I can also have a notes view and a printer, notes printer, and a slide printer. Slide printer lets me like preview everything without being one slide per page. The printer is what the students would print out, and the notes view is what they would look at on the screen if they were looking at the notes. So I get all 4 of those views. I also generate Word documents or whatever I need from the same source, and I don't have to just have a separate file for each. So if I were going, let's see, if I go to the notes printer view, see if this works. I then format the thing, if it's still working. And some of those are in the background. Let me come over. Let's load the new version. Oh, that one doesn't work. I did one of these this morning. Let's go to the notes view. Oh, there we go. And so there's a screen notes view. Notice it's the same thing I just showed you in slide view. And so what I saw is not what I got, but what I had, I can get more than that. The screen view would have all sorts of color coding and things in, and if the students wanted to print it, the slide view would be black and white. Condensed, so you don't waste a lot of ink if you're using an inkjet, and it would have restricted pictures. It also means I would put pictures on the in-class slide view that if I didn't have permission to show them other than spare use, I could then show them in class, but generate the notes, which would be missing the pictures because I didn't have permission to publish them for the whole internet, and they would then could see the notes without having all the extra pictures. Okay, so that's a little bit on a different approach to doing text and how you might get hold of your editor to manage everything yourself. So if you want to do something the editor didn't let you do, you can actually put it into Lua and do it. Okay, questions? Yes? Oh, Mitchell? Oh, wait for the...
So am I right to understand that you generate functions for each key for all the modifiers? So like for the A key, you had the key code 65.
Yes, I'm going to generate 2 to the third, 8 different handlers for that. They may not all be used.
Okay, so for every key on your keyboard, you have 8 handlers.
Yes.
Is there some sort of memory hit when you load up the editor?
No.
So you notice?
I've never noticed anything. That's what computers keep getting faster, and you have more memory. And the whole idea is to have the computer working for you instead of you working for the computer. So if there were a problem, then I would have to change it. But with these fast computers, and Lua is more than fast enough to handle the keystrokes, so yeah, it works fine.
Okay.
And having a consistent way to handle every possible key, you have however many keys times 8, it simplifies the interface. You don't have to put all these checks on whether you did what, because it just maps into there, that one routine.
And so then for the unmodified keys, so just typing A, you also have functions to insert the character A, or do you leave that to the Scintilla component?
Oh, no, well, you make the call. SciTE has these calls where you can insert text at a certain point. So when you do A, you simply call it and do that.
Right, so you call and tell the editor to insert A. You don't just return true in your on key to let the editor itself.
Oh, no, I'm not going to let the editor do that. I want control, so I make sure it gets where it's supposed to be.
Okay.
Because let me try. Okay. So I'm not sure. Oh, let me just. If I do this, it'll show me the actual code. Okay. I need to pull. So I'm looking at this in Notepad, and so here's all the stuff that's in there. There's the key defines. It's going to add key add. So you generate all those, but that's all generated, so I'm not worried about it. Here's key add, but before I do it, I check. Let me make that a little bigger. Because if I'm typing and I'm in HTML mode and I type semicolon, I want it to expand that to the ampersand semi. If it's a left parenthesis, left bracket, left curly brace, it's going to check the balance of this and add another one at the end. But if I put a left bracket in and that closes the brackets for the line, it's not going to put another one in. Remember I typed the left bracket, it automatically put the right one in? Well, I want it to check. If I put a left bracket in and there's already a closed one for it, it's not going to do it. Just like if I type double quote for a string, it's going to put another double quote in unless there's already one there or it's closing the string, then it doesn't. So it has to look at the context at what you're in. Looks if there's a backslash, does some things, because sometimes it has to add something. If there's a dot, it'll do something. And finally, when it gets to the end, if it's a certain character there, it'll just move past it because it's supposed to. And then finally, it calls text add, and it adds that text using Scintilla, or the SciTE editor, which calls Scintilla.
Okay, thank you.
Now, you're not going to want to do exactly what I did, but you can do whatever you want. And that's the whole point of it. Any other questions? Okay, thank you.